Hello everyone, welcome to the channel The Host Code. In today's video we are going to solve the LeetCode Daily Challenge question. The problem is called Find Lucky Integer in an Array. So first I'll walk you through the brute force solution to understand the logic, and then we'll move on to a more optimized approach using Java. So let's get started with the problem statement. So the problem is simple but interesting. Given an array of integers, lucky number is an integer that has a frequency in array equals to its value. Okay, so return the largest lucky number in the array. If there is no lucky integer, return minus. Okay, so let me show you the quick example. So array 2, 2, 2, 3, 4. So the only lucky number is 2 because frequency is 2 and the value is also 2. And this is another case where you have multiple lucky numbers and you need to choose a maximum value among those, right? So 1 has 1, 2 has 2 frequency, and 3 has 3 frequency, right? All are lucky numbers. Return the largest among them. So 3 is the largest among them and we will be returning 3. And in third example, there is no largest number, there is no lucky number. So the, the output would be minus 1, right? So let's start with a brute force approach, like brute force approach. So in this brute force approach, the idea here is to loop through every number in the array, loop every number in the array, okay? And for each number, we would be counting how many times it appears, right? For each number, we would be counting count plus, right? For each number, we're counting it. And then we need to check. You have the count of the number, right? And we need to check that is the value is equals to the frequency, right? So we need to check if the count is equals to the number itself or not. If yes, if yes, we need to keep track of maximum number. We need to keep track of maximum number because we might not know how many max numbers would be there, how many, sorry, lucky integers would be there in an array, right? So we need to keep tracking the max number. So and then we need to return, and then we need to return it. So this would be our approach in the brute force example. So we'll be discussing the code now. So let's try to write the code, maybe a pseudo code over here. Like we will be initializing a max as -1 as discussed before in our brute force approach in the previous slide. And then we'll start the loop for every integer in the array. Every integer in the array. And we will try to keep the count initialized as 0, and then we will loop again with trying to find this exact number, how many times it's occurring in the array. So we need to run the loop again, right? So this, if you find the same number in the array, you would be increasing the count, right? You would be increasing the count. And then this loop ends. This loop ends. So you have got the count of that particular number. If I say 1, 2, 2, 3, 3, 3. So we are right now here, the x value is here, the x contains 1, and y will traverse all over this array, right? So it would be starting with 0th index and moving all over the last, all over to the last, right? So it would be finding x, and it will try to see if x is equals to this value. Yes, it is equals to that value. So it would be increase, it will increase the count would become 0 to 1, right? And it would move forward. There will be no one, there will be no match with the number. So like that, it will traverse all over the array and will get the count, and the count would be updated. Since the count has been updated, we need to make track of the maximum number, right? So uh, we have got the number, we have got the frequency, and we need to check it right now. And how will you check it, right? How will you check it? Just try to write over here. Okay, if the count, the count which you have got here is equals to the value, is equals to the value, count is nothing but the frequency of that number in that array. So if the frequency is equals to the value, then you would be adding it to the your max, right? uh, Not add, you would be initializing it with it, right? So max would be given this value. So how you're giving it that? You need to check also, right? You need to check that what is the largest number. So math dot max, and max comma x, right? So it would be storing 1, and the next time it would be storing 2, and the next time it would be storing 3, and it would return max. So if it gets any value over here, if it finds any lucky integer over here, the max would be taking that value and returning it. If it did not find any lucky integer, it would be returning us -1, right? So now let's break it down again. Let's check our steps which we have written over here. Okay. So first we have initialize max number to -1, which means no lucky number found yet. So for each number x in the array, we how many times it appears by looping through the array again. If we count how many times it appears by looping through the array again, if the x appears, we would be increasing the count. And finally, if the count, if the frequency, count in the sense frequency, is equals to x, we would be changing the max variable. And then after traversing all the array, after completing all the function loop, we would be returning the value. If it finds out any lucky number, it would be giving us the value of the lucky integer. If not, it would be returning us with the value -1. Okay. So this approach, um, this approach has time complexity, right? Time complexity. What would be the time complexity of this number? So we have one loop and we have another loop inside the same loop, right? So time complexity would be bigger of n square, right? Because of the nested loops. Because of the nested loops, the time complexity is n square, right? So how to optimize this. How to optimize this? Have you thought about any solution to optimize this? So we would be discussing an optimal solution for that now. Okay. So now let's optimize the solution using approach, an optimal approach using HashMap. What would you what would we doing with HashMap? So instead instead of checking instead of checking frequency every time manually, we count all the frequency in one pass. In one pass, right? So have you got any idea how we'll be doing this? Yes, now let's discuss about the optimal approach using HashMap. So we will initialize a map, integer, a frequency map, if you say new HashMap, and we will loop over the array. We loop over the array. We insert every integer into the map with its frequency. Let's see how. Frequency dot put, which inserts the value for x, put x, frequency dot get or default x comma 0 plus 1. Okay, so let's visualize this. How would we do? Okay, so right now we have, let's imagine 2, 2, 3, 4, right? So the hash map puts this value first 2 into the map and the frequency would be 1, and then it again iterates over the next number and it finds 2 again. So right at now it would be getting the frequency of the existing 2 and adding it plus 1, so it would become 2. So like this it would be looping all over the array and it would be increasing the frequency of array if it matches the number. Okay, that's how we will be using a single loop for calculating the frequency and also how many numbers are in the array. For each number, we will be calculating the frequency at a time, right? So we got the frequency for each and every number. For 2 is 2, 3 would be 1, 4 would be 1. So next, it is the same logic which we have written before. It is the same logic, like max number minus 1. For hash map, we will be iterating through the hash map. For each map entry, please loop over the hash map, traverse over the hash map, and frequency dot set. Give me the set of that each value. This is the set. This is considered as a set. Okay. So we will be taking an integer number and entry dot get key. It gives a key value value of the key, and integer count, which is frequency, which gives the entry dot get value of the, which this is the key, this is the value. We got 2, 2, and then we will see like number is equals to count or not. If yes, then max equals to math dot max, max and number, okay, and return max, okay. This is how the optimal approach looks. So let's try to code this. So let's try to code the optimal approach now. Let's initialize the map. Let's call it as count. Okay. For each integer in the array, we will be traversing each and every integer in the array and we'll be inserting the value, inserting it as a key, inserting it as a key, which is x, and we'll be calculating its frequency by adding 1. If there is no number, we will be adding a default. If it's the default, x comma 0, okay, plus 1, right? So we got the frequency of the each and every integer in the array. So we'll be initializing the max with -1 for each map dot entry, for each map dot entry integer entry frequency dot entry set. We will be initializing a number. We will be initializing a number. Entry dot get key, and initializing a count, which is already stored in the hash map. We will be just getting that value. Okay, we'll just see if both are equal. If yes, then we let's change the variable max variable to math.max. and then return it. Return what? Max. Okay. First we have initialize a frequency map and then try to calculate the frequency of each variable, each number in the array, traversing all over through the array, and then we just initialize the max variable. Again, we traverse over the hash map and try to get the number and the count key and the value. If the both are equal, we are trying to uh, change the max variable, and then after the loop, we are just returning the value. Let's try to run this. Map dot entry. Oh, sure, sorry. It should be a capital. Yeah. Okay. So I just want to explain it again, like what's happening here. So first we are creating a hash map to store the frequency, and in the first loop we are filling the map with counts. Then we look through each entry in the map. If a number is equals to its frequency, we consider it as a lucky number and update the max. This approach only loops through the array once, right? Here once. So it is O of n. It gives us a complexity of O of n. So much better than the brute force approach, right? So this is all. All right. That was a lead code find lucky integer in the array. We saw both the brute force and the optimized solution in the Java. I hope you understand the logic behind the both. If you found this helpful, do give it a thumbs up, leave a comment if you have any questions, and don't forget to subscribe for more LeetCode solutions in Java. Thank you. See you in the next video.